Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video I will be solving the paper 4 exam for February-March 2018. So let's get started. Question 1 says define acceleration. It is the rate of change of velocity, not speed. Part B says figure 1.1 shows a speed time axis for the graph of the motion of a car. The car starts from rest. From time equals 0 to time 15 seconds, the car has constant acceleration to a speed of 28 meters per second. Then from 15 seconds to 32 seconds, the car has constant speed. From time 32, the car has a constant deceleration of 2 meters per second squared until it comes to rest. On figure 1.1, draw the graph using the space below for any calculations. For the first two parts, we do not have to calculate anything. We have the starting point at time 0. The speed is also 0, and at time 15 seconds the speed was 28 meters per second. Then the speed stayed at 28 meters per second until 32 seconds. For constant acceleration, the graph is a straight line from 0 to 28 meters per second, and for constant speed we draw a horizontal line from this point to this point. Now we need the time coordinate for the final speed 0 after the deceleration has ended. So we have initial velocity 28, final velocity 0, acceleration is equal to negative 2 meters per second squared, and we need to calculate the time using equation A equals V minus U over T, then time equals V minus U over A, and then we substitute V equals 0, U equals 28, and the acceleration equals negative 2. That gives an answer for the time of 14 seconds after 32 seconds. So the total here would be 46 seconds at speed 0. So labeling this point where we end the graph. So this is the point where the speed will be 0. And for constant deceleration, we also draw a straight line going down like this. So this is the final shape of the graph. Double I says from time 15 seconds to time 32 seconds, the path of the car is part of a circle. So we're moving with constant speed in circular path. For this motion, state the direction of the resultant force on the car and what happens to the velocity of the car. The direction of the resultant force is always towards the center of a circular path. And for the velocity, it is changing, although the speed is constant because the direction is changing. Question 2a says a force is used to move an object from the Earth's surface to a greater height. Explain why the gravitational potential energy of the object increases. We can say that work is done against gravity and is stored in the object as gravitational potential energy. Part B says figure 2.1 shows a train moving up towards the top of a mountain. The train transports 80 passengers, each of average mass 65 kilograms, through a vertical height of 1,600 meters. Calculate the increase in the total gravitational potential energy of the passengers. So the gravitational potential energy is equal to mgh. And we have the mass is equal to the 80 passengers multiplied by the mass of one passenger. Then we multiply by 9.8 g and the height 1600. That gives an answer of 8.1536 times 10 to the power of 7. We can approximate that to 2 or 3 significant figures according to the question's numbers. So we can write it as 8.15 times 10 to the power of 7, and the unit here is joules. Part C says the engine of the train has a power of 1500 kilowatts. The time taken to reach the top of the mountain is 30 minutes. Calculate the efficiency of the engine in raising the 80 passengers 1600 meters to the top of the mountain. Efficiency is equal to the output power or the useful output power, which is using the energy we calculated before, gravitational potential energy gained, divided by time. And then we divide by the input power and multiply by 100 to get a percentage. We can say that the energy 8.1536 times 10 to the power of 7 divided by the time, which is 30 minutes multiplied by 60 seconds to convert it to SI units, divided by the input power 1500 times 10 to the power of 3 for kilo. All this is multiplied by 100 to get a percentage. This is 3.01985, which we can approximate to 3.0%. Question 3a says complete the statement by writing in the blank spaces. The moment of a force about a pivot is equal to what multiplied by what? That would be magnitude of force multiplied by the perpendicular distance from a pivot or a point. Section B says figure 3.1 shows a horizontal rod of length 2.4 and weight 160 newtons. The weight of the rod acts at its center. The rod is suspended by two vertical ropes X and Y. The tension in each rope is 80 newtons. State the name given to the point at which the weight of the rod acts. That would be center of mass or center of gravity. Double I says calculate the mass of the rod. The mass is equal to the weight divided by the gravity field strength. So we divide 160 by 9.8. That gives an answer of 16.3265. We can approximate that to 16 kilograms. Triple I says the rod is in equilibrium. Use data from figure 3.1 to explain why. We need to check that the resultant force is 0 and the resultant moment is also 0. Checking the forces in the diagram, we have two upward forces and one downward force, and the two upward forces each are 80. So we write down total upward forces equals 80 plus 80. That gives a total of 160 newtons, and the total downward forces is one force of 160 newtons, so they are balanced or they cancel each other. And for the moments, we need to pick a point. We can take at point X or Y or in the middle. For example, we are going to take moments about point X or rope X. We need to calculate the clockwise moments and the anti-clockwise moments about this point and check if they are balanced or not. If we take the pivot at this point, the 160 Newton force creates a clockwise moment and the 80 Newton force creates an anti-clockwise moment, and this force has no moment because it is passing through the point we are considering as a pivot. And the distance from the 160 Newton to X is half 2.4, which is 1.2, and from Y to rope X, the total distance is 2.4. So for the clockwise moment, we have a force 160 multiplied by a distance 1.2. That gives an answer of 192 Newton meters. And for the anti-clockwise moment, we have a force of 80 and the distance 2.4. That also gives an answer of 192 Newton meters. So they are balanced again, or they cancel each other again. Question 4 says figure 4.1 shows a cold plastic spoon that has just been placed in hot liquid in a cup. Describe in terms of molecules why the temperature of the whole of the spoon increases. We can start by saying that liquid molecules collide with the spoon and transfer energy to the spoon by conduction. Then the molecules of the spoon vibrate faster and collide with each other, transferring energy from the faster molecules to the slower molecules or slower ones. Question B says the plastic spoon is replaced by a metal spoon. Describe an additional process by which the temperature of the whole of the spoon increases. We say that metals have free electrons that travel through the atoms or the molecules and transfer some of their kinetic energy. Question C says the cup contains 150 grams of liquid of specific heat capacity 4.2 joules per gram degrees Celsius. The unit for the mass and the specific heat capacity for mass is grams, so we do not need to convert. When the cold spoon is placed into the hot liquid, the temperature of the liquid decreases from 80 to 56 degrees Celsius. Calculate the loss of thermal energy from the liquid. We can use the equation Q equals mc delta theta, and the energy is equal to the mass 150 multiplied by C 4.2, and then delta theta, the difference between 80 and 56. That gives an answer of 15,120. We can approximate that to 15,000 joules. Question 5a says figure 5.1 shows the apparatus used to observe the motion of smoke particles that are in the air in a box. Light from a lamp enters the box through a window in one side of the box. The smoke particles are observed using a microscope fixed above a window in the top of the box. The motion of a single smoke particle is observed through the microscope. In the circle shown, sketch the path of this smoke particle. We are talking here about Brownian motion, so if this is the smoke particle, we have to draw straight broken lines but having no pattern at all, so something like this. Double I says explain why the smoke particle follows the path that is observed. We can start by saying that the air molecules around the smoke particle collide with the particle and rebound, exerting random forces on it. So since the forces are random or the collisions are random, the motion will also be random. Part B says a tennis player is practicing by hitting a ball many times against the wall. The ball hits the wall 20 times in 60 seconds. The average change in momentum for each collision with the wall is 4.2 kilograms meters per second. Calculate the average force that the ball exerts on the wall. We can use force is equal to the change in momentum divided by the time. The only problem here, we have the change in momentum of one collision, but the time for 20 collisions. So we can calculate the total change in momentum, 20 times 4.2 for all collisions, and then divide by the total time, 60. Or we can calculate the time for one collision by dividing 60 over 20 and use the change in momentum of one collision and the time for one collision. They will both give an answer of 1.4 newtons. Question 6a says figure 6.1 represents the electromagnetic spectrum starting from radio waves, then microwaves, and we have unlabeled here sections of the spectrum with the visible light in the middle, and we are required to identify the unknown regions. The one between microwaves and visible light is infrared, and after visible light we have ultraviolet, then we have X-rays, then gamma rays. Question B says a source emits visible light. Figure 6.2 shows a ray of red light from the source incident on the face XY of a glass prism at point S. The angle of incidence I of the ray is 35 degrees. The refractive index of the glass rod for red light is 1.5. Calculate the angle of refraction in the glass at S. We can use n is equal to the sine of the angle in air over sine the angle in the medium. Then we substitute 1.5 is equal to sine angle in air 35 divided by the unknown angle of refraction in the medium. We can replace these two and divide sine 35 over 1.5. That gives us sine the angle. Then we press shift sine answer on the calculator to get the angle R, which is approximately equal to 22.4814. We can approximate that further and say it is approximately 22 degrees or 22.5 degrees. Double I says on figure 6.2 draw the refracted ray at face XY and the ray emerging from face XZ of the prism and label this ray R. First, the ray does not continue in the same direction. As it slows down in the glass, it bends towards the normal, and at this point we have a new normal looking like this. But moving away from the glass into air, the light bends away from the new normal, so it will be like this. And we label this ray R for red and the directions of the travel of the ray. Triple I says a ray of blue light follows the same path as the ray of red light incident on the face XY. On figure 6.2, draw the path of this ray in the prism and emerging from the prism and label this ray B. Now blue has a larger refractive index at S and bends more than red light, so moving towards the normal, but we do not pass the normal. It will bend more towards the normal, but not by much. Now we have a new normal here, and again we will bend away from the normal, but we have a larger angle of incidence, so you will have a larger angle of refraction, not parallel rays, but like this. And we label this ray B for blue and the directions of the rays. This was a sketch, so we did not need to measure any angles here, and this is the final shape of the diagram. Question 7a says the speed of a light wave in air is 3.00 times 10 to the power of 8. The refractive index of water is 1.33. Calculate the speed of light wave in water. So the refractive index is equal to the speed in air divided by the speed in the medium. So 1.33 is equal to 3 times 10 to the power of 8 divided by the unknown velocity. We replace these two and divide 3 times 10 to the power of 8 over 1.33. That gives a velocity of 2.2556 times 10 to the power of 8. We can approximate that to 2.3 times 10 to the power of 8, and the unit is meters per second. Part B says figure 7.1 shows parallel wavefronts of light wave in air incident on a boundary with a transparent plastic. On figure 7.1, we are required to draw the positions of the 4 refracted wavefronts in the plastic and draw an arrow to show the direction of travel of the refracted wave. And then we label the angle of refraction R of the light wave. First, we can continue the direction of the wave until we meet with the boundary between the two media. So like this, we continue the line. And at this point, we draw a normal. So we are going to use a protractor, and its center is at this point, and measure 90 degrees on the line of the boundary and use the protractor as a guide. as if it was a ruler to draw the normal at this point. And the normal is a dashed line to show that it is not part of the wave, it is an imaginary line that we use to measure angles. Then we say that the wave is bent towards the normal from this point, so we can bend the ray towards the normal and draw the new direction. Then we use this direction to draw perpendicular lines on it for the wavefronts inside the transparent block. First, we place the 90 degrees on the direction of the refracted wave, like this, and we use the flat edge of the protractor as a ruler at this point where the wavefronts met the boundary. So going like this at the first point, and we draw the first refracted ray. We move the protractor further up and reach the second wavefront. So like this, parallel to the first one. We repeat for the third wavefront and for the fourth wavefront parallel to them. So this is the final shape of the diagram. We use an arrow to label the direction of the refracted wave, and the angle of refraction is between this direction and the normal. So this is angle R. Question 8a says the lamp of a car headlight is rated 12 volts and 50 watts. Calculate the current in the lamp when operating normally. So current is equal to power divided by voltage. We have 50 divided by 12. That gives an answer of 4.16 recurring. We can approximate that to 4.2 amperes. Question B says a car is driven at night in a journey. The total charge that passes through the 12-volt battery is 270 kilocoulomb. Calculate the electrical energy transferred. We use energy is equal to voltage multiplied by charge. So 12 multiplied by 270, but times 10 to the power of 3 for kilo. This gives an answer of 3.24 times 10 to the power of 6 joules. Double I says the fuel used by the car provides 3.6 times 10 to the power of 4 joules for every 1 centimeter cubed. Calculate the volume of fuel used to provide energy calculated in BI. We can use cross multiplication. So if 3.6 times 10 to the power of 4 joules are given by 1 centimeter cubed, how many centimeter cubed are used when 3.24 times 10 to the power of 6 joules are used? We can divide this by this. We get an answer of 90 centimeters cubed. Question 9 says figure 9.1 shows the current potential difference graphs for a resistor and for a lamp. Part AI says the potential difference across the resistor is increased. Tick the box that indicates the effect on the resistance of the resistor. For the resistor, we have a straight line, which means that the resistance is constant or does not change. And then again for the lamp, the curve is pointing towards the potential difference axis or bending towards the voltage axis. This means that it needs more energy as current increases. So this means that the resistance is increasing. Part B says the potential difference across the lamp is 6 volts. Calculate the resistance of the lamp. Resistance is equal to voltage divided by current, and we can get the current from the graph. At 6 volts, the current on the y-axis for the lamp is 4.4. So we divide 6 by 4.4 to get an answer of 1.36 recurring. We can approximate that to 1.4 ohms. Part C says the lamp and the resistor are connected in parallel to a 6 volt supply, so they both have voltage 6 volts. Calculate the current from the supply. It is equal to the total current or the addition of currents from the components. Going back to the graph, we already did the current for the lamp, and the current for the resistor at 6 volts is 4 amperes. So we add 4 plus 4.4 to get a total of 8.4 amperes. Part D says the lamp and resistor are now connected in series to another power supply, and the current is 4 amperes in the whole circuit. Calculate the total potential difference. In series, we add the potential differences. So at 4 amperes, we can get the current for the lamp here is approximately 4.9. This is the voltage, not the current, sorry. So this is 4.9 volts. And for the resistor, we have the voltage 6 volts at the same current. So we add 4.9 plus 6 to get an answer of 10.9 volts. Question 10a says figure 10.1 shows a straight wire AB placed in a magnetic field between the poles of a magnet. The ends of AB are connected to a galvanometer. When AB is moved vertically, the needle of the galvanometer shows a deflection. State 3 factors that affect the size of the deflection or the size of the induced current, because the galvanometer is basically an ammeter. We can say the strength of the magnetic field or the strength of the magnet. We can also say the speed of motion. and the length of wire inside the magnetic field. All these, if increased, the induced current will also increase. Part B says figure 10.2 shows a transformer. The primary coil P has 8,000 turns and an input of 240 volts. The secondary coil S has an output of 12 volts. Calculate the number of turns in the secondary coil. We can use NS over NP is equal to VS over VP. Then we substitute NS over 8,000 is equal to 12 divided by 240. Then we do cross multiplication. 8,000 times 12 over 240 gives an answer of 400 turns on the secondary coil. Double I says a circuit containing a resistor is connected to the terminals A and B. A direct current is required in the resistor. On figure 10.2, draw this circuit. Now a transformer produces an alternating current, which means we have to connect something that converts AC to DC. That would be a diode or a rectifier circuit. Then the resistor in series, and then we close the circuit by connecting to the other terminal. Question 11a says to ensure the safety of workers in laboratories where radioactive sources are used, describe how radioactive materials should be stored. We can say in containers lined with lead or thick metal containers, should be handled using long forceps or long tongues for protection. Question B says complete the table below for 3 types of emission from radioactive sources. We have the nature of each emission. An electromagnetic radiation, that would be gamma rays. For helium nucleus, we have alpha particle. For an electron, we have beta particle. And the ranges in air, electromagnetic radiation several kilometers. For the alpha particles, we have a few centimeters, and for an electron, we have a few meters. And they are absorbed by, for gamma radiation, we can say thick lead or thick concrete. For a beta particle, we can say 5 millimeters of aluminium or any metal with an approximate density. Question C says state the type of radiation emitted when an americium nucleus 241-95 decays into a neptunium nucleus 237-93. Here the nucleon number decreased by 4 and the proton number decreased by 2, so this is an alpha emission. Double I says a phosphorus nucleus 32 and 15 decays into silicon nucleus 32 and 16. The nucleon number did not change, but the proton number increased by 1. That is caused by a beta emission. So this was the end of the exam. I hope you enjoyed this video and found it useful. If you did, please give it a thumbs up and subscribe to the channel, and I will see you in another video.